This video will cover moderate questions regarding the topic of integrating logarithmic functions. Number 1, let's divide using long division. X cubed minus 2x squared plus 4x minus 13 divided by x minus 2. X times x squared make x cubed minus 2 times x squared is 2x squared minus cancelled, 4x is down and minus 13. There's no x squared, so plus 0x, then plus 4 times x is 4x, 4 times minus 2 is minus 8, and then minus 5 is left over. The numerator, which is x cubed minus 2x squared plus 4x minus 13 equals x minus 2 times the quotient x squared plus 4 minus 5. Then divide by x minus 2 on each side equals, can we use it separately? This part, x squared plus 4 minus 5 over x minus 2. Or you can use the sensitive division. Write down only coefficient part, 1 minus 2, 4 minus 13, then divide by, the divisor is x minus 2. Insert the 0 of the divisor to the left. Since the divisor is x minus 2, the 0 is x equals 2. Then 1 down, 1 times 2 is 2, then add them together, 0. 0 times 2 is 0, add them together makes 4, 4 times 2 is 8, add them together make minus 5. Then this part is quotient, this part is remainder, which is x squared plus 4. So quotient is x squared plus 4, minus 5 is remainder here, then 2 then means x minus 2, which is divisor. Then back to the original, we can rewrite as the integral of x squared plus 4 minus 5 over x minus 2 dx equals, use the power for integration, x cubed over 3 plus 4x minus 5 at an absolute value of x minus 2 plus c. This is the final answer. The integral of 1 over x dx equals, at an absolute value of x plus c. I already explained in beginner. Usually students use the U-substitution when integrating 1 over x plus k dx form. I will show you that you don't have to. Let u equal x plus k, du equals dx, then all x change into u. 1 over x plus k is u, dx is du, equals, and then the absolute value of u plus c, and then absolute value of x plus k plus c. Use the coefficient of x is 1. We just do it as we do when integrating 1 over x. Number 2, synthetic division cannot be used here because the divisor is quadratic. Only long division can be used. X squared minus 3, x to the power of 4 minus 2x cubed plus 0 times x squared. Here, please remember, we use 0 coefficient for any missing terms. Then plus 2x minus 9. Then x squared times x squared is x to the power of 4 minus x squared times 3x minus 3x squared. Cancelled. Minus 2x cubed plus 3x squared plus 2x. Then minus 2x minus 2x times x squared is minus 2x cubed. Minus 2x times minus 3 is plus 6x. Minus is cancelled. 3x squared minus 4x minus 9. Then plus 3. 3 times x squared is 3x squared. 3 times minus 3 is minus 9. Then cancelled. The remainder is minus 4x. Dividend equals quotient times divisor plus remainder, then over divisor, which is make separate, cancelled. Another one. So quotient is x squared minus 2x plus 3 plus remainder is minus 4x over divisor is x squared minus 3. Number 2, we can rewrite as this one, x squared minus 2x plus 3 minus 4x over x squared minus 3 dx. Here we break the integrand into two parts. The first one and the second one. The first part should use the power rule and the second part should use the U-substitution. So x cubed over 3 minus 2 times x squared over 2 plus 3x minus, let u equal x squared minus 3, then du equals 2x dx. There is 4x dx, then times 2 on each side, 2 du equals 4x dx. Then back to the original, the integral of all x into u, 4x dx equals 2 du over x squared minus 3 is u equals x cubed over 3 minus cancelled x squared plus 3x minus 2 times ln absolute value of u plus c equals x cubed over 3 minus x squared plus 3x minus 2 ln absolute value of u was x squared minus 3 plus c. Number 3, this rational expression has a degree of 3 in the denominator, but it can be done simply without division. Just swap the place x squared and 2. So the integral of x cubed plus 2 plus x squared over x cubed plus 2 dx equals, then write separately the integral of, like this, x cubed plus 2 over x cubed plus 2 plus x squared over x cubed plus 2 dx. Here we break the integrand into two parts. The first part is 1 and the second part should use the U-substitution. Antiderivative of 1 is x plus, let u equal x cubed plus 2, then derive on each side, du equals 3x squared dx. There is only x squared dx, then divide by 3 on each side, d over 3 equals cancelled x squared dx Then back to the original, change all x into u. The integral of this part is du over 3, 1 over this part is u equals x plus 1 over 3. Then integral of 1 over u is ln, absolute value of u plus c equals x plus 1 over 3 ln absolute value of x cubed plus 2 plus c. Number 4. When students see this problem, they will put ln x as u. So let u equal ln x, then du equals 1 over x dx. Let's replace all x into u. The integral of minus ln x is u squared 1 over x dx is du equals the integral of 2 minus u squared equals 2 minus u times 2 minus u equals 4 minus 2u minus 2u minus 4u plus u squared. Then back to the original, 4 minus 4u plus u squared du. Using the power rule for integration equals 4u minus 4 times u squared over 2 plus u cubed over 3 plus c equals 4u minus 2 times 1, 2 times 2, 2u squared plus u cubed over 3 plus c. The final answer is 4. U was ln x minus 2 ln x squared plus ln x cubed over 3 plus c. Now, let's think about another way. Let u equal 2 minus ln x. Then derive on each side. Du equals minus 1 over x dx. Then times minus 1 on each side. Minus du equals 1 over x dx. Now change all x into u. The integral of this whole part is u squared. Then 1 over x dx is minus du. Then minus the integral of u squared du equals minus u cubed over 3 plus c. Then minus u was 2 minus ln x cubed over 3 plus c. How is it? It's not that the first solution is wrong, but the second method is faster and easier. In this problem, we need ln x, not ln x squared. But don't worry, just use the logarithmic property. Ln x squared equals 2 can go down to ln x. So we can rewrite as the integral of 1 over x times this part is 2 ln x dx equals 1 over 2, move here, the integral of 1 over x ln x dx. Let u equal ln x, then du equals 1 over x dx equals 1 over 2 integral of this part 1 over u and 1 over x dx is du equals 1 over 2 and an absolute value of u plus c. The final answer is 1 over 2 ln, the absolute value of ln x plus c. In this problem, if u equal x to the power of 1 over 3, then du equals 1 over 3 x to the power of minus 2 over 3 dx. Then times 3 on each side. 3 du equals x to the power of minus 2 over 3 dx. Then we can rewrite as 3 du equals 1 over x to the power of 2 over 3 dx. Change all x into u. The integral of 1 over this part, u plus 4, this one and this one, makes 3 du equals 3, and then the absolute value of u plus 4 plus c. The final answer is 3 ln. Absolute value of u is x to the power of 1 over 3 plus 4 plus c. But how about this? Let u equal this whole thing x to the power of 1 over 3 plus 4. Then du equals 1 over 3 x to the power of minus 2 over 3 dx, which is the same as this one. That means 3 du equals 1 over x to the power of 2 over 3 dx. Now change all x into u. The integral of 1 over this whole thing is u, and 1 over x to the power of 2 over 3 times dx, this part is 3 du, equals 3 times the integral of 1 over u is ln absolute value of u plus c. Then the final answer is 3 ln the absolute value of x to the power of 1 over 3 plus 4 plus c. This one is more simple than the first one. If there is a number next to the variable you want to replace with u, don't care and just put the whole of it as u. This question is not simple. At first, students have no idea what u is. Let's put x plus 2 in the denominator as u. Let u is x plus 2, then du equals dx. From here, minus 2 on each side, u minus 2 equals x. Constant 3 moves here. The integral of x is u minus 2 over x plus 2 is u squared, then dx is du, equals 3. Integral of make separate u over u squared minus 2 over u squared du equals 3 times the integral of 1 over u minus 2, make the power form u to the power of minus 2 du, equals 3 times ln absolute value of u minus 2 times, use the power for integration, u to the power of minus 2 plus 1, which is minus 1 over minus 1 plus c, equals 3 times ln absolute value of u, make positive, plus 2 times 1 over u plus c. Now back to the original value x. 3 ln absolute value of u was x plus 2 plus 6 over u, which is x plus 2 plus c. This integral is very special. We can use U-substitution, and even though we know that we are in the part of integrating logarithmic functions, we can imagine how to integrate. So the first, the integral of secant x multiplied by secant x plus tangent x over secant x plus tangent x dx. Expand the numerator, secant squared x plus secant x tangent x over secant x plus tangent x dx. Now you can use U substitution. Let U equal secant x plus tangent x, then du equals secant x tangent x plus secant squared x dx. Then rewrite the integral as this part is u and this whole thing is du. Then ln absolute value of u plus c, which is absolute value of secant x plus tangent x plus c. Now we have a formula. Integrating secant x gives us two formulas. We have found one. Now let's find another one. Secant x plus tangent x times secant x minus tangent x over secant x minus tangent x equals, expand the numerator. This is a plus b, a minus b part, then a squared minus b squared form, secant squared x minus tangent squared x over secant x minus tangent x. Using the trigonometric identity, secant squared x equals tangent squared x plus 1. Move tangent squared x to the left, then secant squared x minus tangent squared x equals 1. So this part 1 over secant x minus tangent x equals secant x minus tangent x to the power of minus 1. Then back to the original. Ln absolute value of secant x plus tangent x is this one. Secant x minus tangent x to the power of minus 1 plus c equals minus 1 can go down, minus ln absolute value of secant x minus tangent x plus c. Now we have two formulas for integrating secant x. This one is the last one. Integrating cosecant x is the same as integrating secant x. So integral of cosecant x times cosecant x plus cotangent x over cosecant x plus cotangent x dx equals the integral of, expand the numerator, cosecant squared x plus cosecant x cotangent x over cosecant x plus cotangent x dx. Now we can use U substitution. Let U equal cosecant x plus cotangent x, derive on each side, du equals minus cosecant x cotangent x minus cosecant squared x dx. Then du equals, take out the negative sign, cosecant x cotangent x plus cosecant squared x dx. The numerator is positive, then divide by minus 1 on each side, then minus du equals cosecant x cotangent x plus cosecant squared x dx. Now change all x into u. The integral of this part is minus du over this part is u equals minus ln absolute value of u plus c equals minus ln absolute value of u was cosecant x plus cotangent x plus c. Now we have a formula. Integrating cosecant x gives us two formulas. We have found one. Let's find another one. But this time, let's get the second formula by integrating again from the beginning without changing the formula we have already found. The integral of cosecant x multiplied by cosecant x minus cotangent x over cosecant x minus cotangent x dx equals integral of, expand the numerator, cosecant squared x minus cosecant x cotangent x over cosecant x minus cotangent x dx. Let u equal cosecant x minus cotangent x du equals minus cosecant x cotangent x minus, derive this one, minus cosecant squared x dx. Make positive, we can rewrite as du equals, this part first, cosecant squared x minus cosecant x cotangent x dx. Let's change all x into u. The integral of the whole thing, this part is du over the denominator is u equals ln absolute value of u plus c equals ln absolute value of u was this part cosecant x minus cotangent x plus c. This is the second formula. Now we have two formulas for integrating cosecant x. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.